Hey everybody, in this video we'll talk about finding vertical and horizontal asymptotes of a rational function, quadratic numerator or denominator. So in this video we'll also go through and talk about how we know if a graph is going to cross a horizontal asymptote. Remember, it can never cross a vertical asymptote because we find it the same way as the domain, right? And so we know we can't ever have that x value. But for horizontal asymptotes, we can cross those. So we'll talk about that a little bit after this one. But let's go ahead and look at this function and determine its vertical asymptote or asymptotes. Remember, vertical is where the denominator equals 0. It's the same thing as the domain. So we don't want the denominator to equal 0, but this isn't really a nice way to solve this. We could do the quadratic formula on this, or we could factor it. This factors into x plus 3 times x minus 1. So if x plus 3 equals 0, then we'll get 0 in the denominator. So x plus 3 cannot equal 0. And x minus 1 cannot equal 0, which means x cannot equal negative 3 and x cannot equal 1, right? That's how we found the domain. These are x equals negative 3 and x equals 1 are the equations for my vertical asymptote. So in this case, I have 2. And I'm going to have 1 at x equals negative 3. So there's my vertical asymptote. And I'm going to have another one at x equals 1. Like this. Now for my horizontal, I need to look at the degree of the top and the degree of the bottom. The degree of the top polynomial is 1. So the degree n equals 1. The degree of the bottom, the denominator, is 2. So the degree m equals 2, which means n equals 1 is less than 2, which equals m. Well, we can rewrite that as n is less than m, right? That, if you want to go back and look at the linear over constant over linear video, n less than m means y equals 0 is my horizontal asymptote. So that would be this right here. Okay, so in the next portion of this video, we're going to talk about once we find horizontal asymptotes, how do we know if or when it will cross? So just to reiterate, will the graph of a rational function ever cross a vertical asymptote? No, never. Will the graph of a rational function ever cross a horizontal asymptote? Sometimes it does, okay? But not every time. So let's look at this one. Let's find the horizontal asymptotes. By the way, the vertical asymptote, will this denominator ever equal 0? No. This one actually doesn't have any vertical asymptotes. So let's talk about the horizontal asymptotes. So the degree of the top, n equals 2. The degree of the bottom, or the denominator, m equals 2. So they're equal. N equals m. Which means we have number 3 on the list of identifying horizontal asymptotes of rational functions. You can go back to my previous video to see that list. Which means my horizontal asymptote is going to be at y equals a sub n over b sub n. And remember, those are just the leading coefficients of our polynomials in the numerator and the denominator. And then in front of this x squared, there's a 1. So a sub n is 2 and b sub m is 1. So y equals 2 is my horizontal asymptote. Okay. So in order to find if and where my function crosses this line, well, y equals 2, right? So let's just plug in 2 for y, or f of x, and then solve. And what I'm going to do is give myself a little more space. So I'm going to plug in 2 into this f of x. So I have 2 equals my function. Where are my outputs of my function equal to 2? That's the question I'm asking. And then I'm going to solve for x, and those x values are going to be the inputs where my function crosses my outputs. So how do I solve this for x? Well, let's get rid of the denominators, the fraction, by multiplying by x squared plus 5 on both sides. Okay, now this 2 is being multiplied by this entire binomial, so I need to multiply the 2 in. So I'm going to get 2x squared plus 10 on the right side, and then these go to 1, so I end up with 2x squared minus x minus 10 on the right side. So I can do some algebraic manipulation here. Subtract 2x squared from both sides. That's going to go to 0, and that's going to go to 0. So I'm left with 10 equals negative x minus 10. Let's go ahead and add 10 to both sides. So this means 20 equals negative x, or the opposite of x. Divide by negative 1. So at what x value do I get an output of 2? Negative 20. So I'm going to have a point that goes through negative 20 and 2. That point is on the horizontal asymptote. So that's where it's going to cross through the horizontal asymptote. Okay, so that's an example of one where it does cross. On this one, we have the same degree, so we're going to have the y equals, the horizontal asymptote is going to happen at 1 over 1, which is just 1. So in order to find if this crosses the horizontal asymptote, let's let our y value, or our output, be equal to our function, and then we find the x value where that happens. So similar to the other one, let's go ahead and multiply by x squared minus 1 on both sides. This is going to go to 1. X squared minus 1 on this side. Remember, this 1 is being multiplied through both of those, so we end up getting x squared minus 1 equals x squared minus 4. Now, if I subtract x squared from both sides, those are going to go to 0, and these are going to go to 0. So I'm left with negative 1 equals negative 4. That's not a true statement, right? Negative 1 will never equal negative 4 in the base 10 model that we're working with. So the graph will not cross. So it does not cross anywhere, because I couldn't get an x value out. I couldn't solve. So it does not cross. Okay. There you go.